Yeah, here we are in chapter 5 of Functional Programming Made Easier. And we're going to write a bunch of list functions, basically. So, just want to make sure there's nothing in here that I should comment out, but I don't think so. And then, yeah. Okay, so we bring in lists, we build, we get this, yep. Okay, and then I think we start writing functions. So, singleton. I'm guessing for all a list of A. Right. It's spelled out like this. Um, so um, so I was guessing that it would be simple enough to write this, but I don't know where it pure comes from a thing. So, but anyway, singleton is the definition of pure. So whatever, we can just write like this, and this should compile. What? What do you mean this doesn't compile? Oh, do I explicitly have to write it? Like, what is going on? Oh, interesting. There's no shorthand. I see. I see. Okay. So I've not written many list functions in PureScript before, so I guess I didn't realize um, what it requires. So that's kind of interesting. So we'll figure this out as we go, obviously. So if you come from a language that has nulls, I want you to realize it's not the same thing. This function checks if a list is empty. Okay. So we're gonna take a list of A and return a boolean. If we have nil, then that's true. Actually, we could do this in. I think it should case underscore of nil true, otherwise false. Right, these are lowercase. There we go. That should compile, I think. Oh, and we need for all A. There we go. Okay, so you can see like I'm out of practice with PureScript when doing like regular stuff like this. Most of what I've been doing recently is writing like halogen stuff, which is mostly just like case matching and so yeah. Anyway, cool. So code for null. Yeah, so this is the alternate way to write it. I tend to write things in case statements these days, and that comes from the fact that I don't know why I like these so much. Probably because of Unison. Unison doesn't have this syntax, and so I wrote this syntax a lot, and I just kind of liked it. So there we go. These ones are easy. I think snock is cons puts an element at the head, so I think puts an element at the end. Okay. So we're gonna have a list of A, and we're gonna give it an A, and we're gonna return a list of A. But we probably want this A to come first. And the reason for that is just because it's easier to pattern match then. Then we can do case of like this. And then actually this isn't that helpful, is it? Yeah, so this isn't that helpful because we can't really do this because we don't have the rest of the list. So here we probably need like a go function. So we're gonna say like go x xs um actually I would rather do this in let syntax, I think. So we're gonna have our yy's, and we're gonna say we need an accumulator. I don't know if they're doing this in Go or Fold, but I'm doing it in Go for now, but probably should do it in Fold. It would be a lot easier. So we need an accumulator. We don't need this because that's just the X. And then we need the current list. So yeah, like this. So if we get nil, whoops. I think this does have to be out here. So if we get nil, then we want to take the accumulator. Oh, but this thing is a cons list. That's the tricky part, right? It's funny how if you don't do this for a while, you just forget how to do stuff. I guess it's good practice then. I'm also still asleep. Okay, so this thing itself is actually a nil, right? So if we have an accumulator that starts to we just need to put y here. No, but that prepends it, right? This is just like prepend the thing, and that's not useful. So cons. Oh, No, that's right. So oh, also it needs a second argument, doesn't it? Oh no, that's just the result. Why am I having so much trouble with this? I don't know. Okay, so we have go, and then we need to build our accumulator, which is like this, and then we just say nil ys. This is x. All right, what are we complaining about here? Probably a lot of things, because the types don't even line up for this. So I think first of all, we should put this on the next line. All right, so what's wrong here? Lots of things. So this thing, first of all, needs to return a list. So we're going to take a list of a list of A, and produce a list of A. That's what this go function is trying to do. So we give a list of A, and you can see that one thing here is, yeah, this would be way easier as a fold, wouldn't it? But I'm wondering if we're supposed to implement this as fold. All right, this isn't gonna work. I also don't think that this is right. This won't compile. What we really want to match is cons y nil, so that we can write like we need the n-1. This one becomes just, if you're given an empty list, do this. If you have one more, then it's y this, and then what goes here is the question. No, this is completely wrong. Recursive functions get you every time. All right. This is the wrong go function, I think. So I think I'm overcomplicating things with the an accumulator. Because if we have ys is nil, then all we need to do is prepend x. That's correct. If we have this list, then we just say yx nil. And then if we have this list, we just keep going. No, that doesn't work. Now, I'm going to keep reading because my head hurts. Yeah, so this isn't going to work. We know that. I don't want to go too far either. We 100% need an accumulator, right? Like, how else do we do this? But I think that we really need to know the state of both of these things, is my feeling. Because the accumulator itself is a list. Okay, we'll wake up. Just need more coffee, right? Hi, buddy. All right. If we get feel like these are the correct options. Now what? So this just becomes exac. If we put exac in all of these places, it should compile, right? It does compile. Makes sense. Okay, so in this case, we need to do this. In this case, we need to y go which means we don't need an accumulator, because this just becomes nil, and this becomes nil. What's the issue here? I thought you got scope type variables. What if we do this? Oh, duh. Oh, and then duh. Okay. Right. So this can be CZ. Z. Oh, actually, we can also just remove this and say case of. Delete that. And then we can just leave the Y here. Nice. Okay. Wow. Man. Feeling very dumb this morning. But this makes perfect sense. We have to build our accumulator up and then just insert X at the end of it, which is what this is doing. And then this one, we just have to protect against the case where there's an empty list and we want to add an X. So the other thing that I kind of want to do is, I mean, I guess we can just like mess around with this a little bit. But like, I think that it should be fine. I think you just run this. All right, so then And then snock. Do we have things like this? Snock? We do. Cool. So we want to snock a 1. We probably need to import. Yeah, so there's today is Veterans Day. And so yeah, I have the day off, which is pretty cool. So we'll just say 1 and nil. Right. Import. Yeah, it's pretty nice. So I figure I'll finish up this chapter and then maybe go for like a motorcycle ride or something. So as list, we can just import all of chapter 5 probably. So then we can try this again. So snock list dot nil. Perfect. So that works with an empty list, which we were expecting it to, but so list cons to nil. Whoops. List nil. Yep. So that does what we expect. And then let's just like list cons to is that right? I keep doing it like that. There we go. All right, cool. So just like some silly tests to make sure it works as we expect, and we also don't break when we had an empty list, because I assume that this will just, well, actually, this will probably say, yeah, it's a case failure. And then do we really need this one? We'll just go YS and hit nil, so it should be fine. Yeah, I think we only need these as well. Cool. Hello? There it goes. All right, sweet. So I think that that's the solution. The other thing is we clearly don't need this go function, right? Because it just becomes x nil, and then cons ys is y knock ys. The only difference is you have to pass the x, I think. What's the issue here? Function. Oh. There we go. Just the wrong types. For what it's worth, I don't know what. I guess we'll find out what. Whoops. We'll find out what is implemented in the book, but my feeling is that this is pretty easy to read. So yeah, the whole thing here that I have to remember is like deal with the base case and then deal with the recursive case. And in this particular case, the recursion is just handled in the tail of this cons list. And that's the pattern that I have to remember, because this is what I was having trouble with, basically. Okay, so now that we've hopefully gotten past our total struggle, Mm-hmm. Mm-hmm. Yeah, so this one is basically just lopping off the y. So you still need the y, and that's why it goes in the front. Like so. Yep. Yeah, I made my call different so that I could write this in this case style. So that's the only difference between our solutions. Okay, so length is probably one I can hopefully figure out. For all a list a to probably int. I think that's probably fine. I can't remember all the details about length, but or all the details about integers. So I think this one does need a go function. Otherwise, there's no way to actually create the accumulator. And again, we're writing these in recursive style, not in a fold style. If we wrote this in a fold style, it would be a little bit easier. So this is gonna be let go, which takes an int and a list and produces an int. So this is x equals case. Oops. Nil is x. Cons is just go x plus 1 ys, and then in go 0 I guess we could just write go 0 like this. I think unknown operator plus. Huh? Oh. Okay, so we're gonna have just delete this. All right, and then we need to see these what's being shadowed. Okay, so hiding sharp. Const. Flip. Okay, so probably like this. And then and dollar. And apply. So I wrote some other functions in here, which is the problem. But they were part of this, so it is what it is. Anyway, we just needed plus. So now this is eta reduced because we don't take the argument. We just take the int here, and then I think this is right. Okay, let's see how Charles writes it. Oh yeah, yeah. So we don't even need a go function. So it's like I'm getting in this bad habit of saying I need a go function, but I really don't because I can just build up a computation. Man. Silly me. So if I decide that I want to go for the go function first, I need to like rethink it at the end because yeah, this is way easier. And then cons. And also we can just use excess here. 1 plus length excess. Nice, way better. And again, it's the same style, so I have to think about this again. So just, you can do this, brain. Brain can't do this, apparently. All right, we'll try that. We'll try that with the next one. All right, so tail recursion. The length function is a great example to use to learn about tail recursion. Before we delve into that subject, we need to talk about how most computers work when calling functions at the lowest level. The way it knows how to return the calling function is by implementing a data structure called a stack. Stack keeps full record of calling process. Last in, first out. Okay. F calls G, G calls H, H returns computation. Yep, this sort of makes sense. Okay, so we have this recursive call here. See that it calls itself once for each element of the list. If the list has 2 elements, then we'll make 2 calls and require 2 slots on the stack. If we have a list of 1,000 elements, we'll need 1,000 elements in the stack. Mm-hmm. Was my go function tail recursive? So let's first copy this and then look at it. I don't know. I'm not doing this in a tail call, right? So I think so, but I don't think about tail recursion very often. And also we would write this with a fold, so again. Like in real life, you would write this with a fold, not a recursive function, I feel like. All right. So can we rewrite length so it's yeah, so introduce an accumulator. Exactly. So we've done all of our computation before recursing because the only computation that needs to get done is x plus 1. Versus at the end of our recursion, which is happening here. Okay, right. Oh, well, okay, very wrong. Oh, right. There's details here. Okay, okay. They're just gonna push this into a go function. Yeah. I see the point here. So this was like just pointing out that now we've put this burden on the user of length to remember that there's an accumulator, which doesn't make any sense. Yeah. Mm-hmm. Yeah. And yeah, this name is just like, I don't know, you see it all the time in Haskell land. But you could call it something else if you wanted to. But if you can come up with a great name for that function, let me know. All right, so tail recursion is great for saving stack space, but it's more difficult to write. Reason about, and makes the code base more complex. To write all of your recursive functions this way uh, is known as a premature optimization. Yeah, I mean, probably. Unless you know you're working with really long lists. Hmm? Cool. All right, head. So head is special because it can fail. Um, keep writing const. Okay. All right. So, yeah, so head can fail, and in many cases, or well, not many cases, but for example, in Haskell, this function is impure and non-total. So, but this version is pure and total, which is great. Okay. Yeah. So there's that. Yep. We get this. Cool. Uh, what is this about? No instance for. Okay. Um. Now imagine we were doing the type inference instead of the compiler. We're trying to figure out the types in this line of code. Oh, okay. I see. It's just okay. So if we just write this, we have no idea what this nil is. It could be literally anything. So it's kind of a problem to write it that way. Okay, I see where we're going with this. But if we can fix the string instance for this list, then it's totally happy with the head because string has a showable instance. Mm-hmm. Wait, why is this a compiler error? Oh, probably because it's like it's thinking that this whole thing is maybe unit. I see. Okay. Beautiful. Oh, yeah, I guess I keep forgetting about this syntax. But anyway. Okay. So tail, very similar function. Oops. Like so. So shorthand for list cons list deconstruction. And I assume that we can write more than one thing in there, but I guess I haven't messed with that much. All right, so there's tail. Fun. Yeah. Okay, so last. So something needs to exist, so it needs to be this. Okay, so case of if we get nil, that's nothing. If we get x, nil, we return x. If we get x, xs, we throw away x and last xs. Okay. Yeah, so basically we're just throwing away the front of the list until we find the last one. Okay. Yeah, I suppose this is fine too. I'm just converting it into a fully recursive call. But I guess like reusing head seems fine. This just does an extra computation that I'm not sure is necessary. Right? Like it requires you to know the length of XS for each time you well, I guess each time you encounter last. Yeah, so it's computing it any time that you recurse for last. So that seems bad. Oh, I think the point is that is this tail recursive? And this is still tail recursive. I think. Pretty sure, yeah. Yeah, because the last piece of recursion is this. This computation will have already happened, so we don't need to carry anything forward. So this should still be tail recursive. Yeah. Yep. So that's what we ended. That's what we wrote. Again, I'm writing things in this sort of case style because I don't know. I just think it's cool. Isn't init just head? Oh no, I know it. Okay, I remember what this is. Um, it basically excludes everything but the head. Or still. All right, so this is nothing, and basically what we want is the last case. Okay, this isn't gonna work, uh, because hopefully it's obvious. I think that we do, in fact, need a go function here. Um, the go function is gonna keep a list of A. And okay, so we've thrown out the case where it's nil, which means that this is like an error, impossible. So basically we're saying like if we have an x and then nil, this becomes nil. If we have x and something else, we x go excess. Something like this? Okay. What does a init do when there's only one element? It's it skips this, so init would throw that away as well. So if you have also like something and nil, that also is nothing. There's probably a more clever way of doing this. I just don't remember what it is offhand. Oh wait, this I see why I'm throwing myself off. I don't think this is the right type definition. Oh no, it is. Okay. Hi. Could you get down, please? Not time for lunch. Thank you. Kitty, you're being silly. Get down so soon. I promise. I'm gonna have to go feed the cat in like 20 minutes because, as you can see, she's getting needy. All right. So what happens if we get nil here? Just nil. It's fine because we shouldn't have that problem. Like we shouldn't really get there because we should have at least 2 elements. So and then all right. So here I think we can just do maybe like you could simplify this by saying if length is less than 2, but like I guess that's the same thing as what I'm doing. What is this complaining about? Oh. I don't remember how to do that in this language. So, but essentially that shouldn't be possible. Which feels like kind of unfortunate that we're doing it this way, but there has to be a better way to do this. I just don't know what it is offhand. So let's keep going and see what comes out. But basically we're protecting against the cases where there's it's completely empty or there's just a singleton list. And then if there isn't a singleton list, then we'll always hit this case first and then this case. So if there was if there's a list with 3 elements, we would basically just get the X, and we can test that this works, but I'm pretty sure it works. It's just kind of ugly. If we were doing folds, we could just say like, what's the length of the list? The whole list, subtract 1 from it, and then just iterate until you get to 0, which actually would probably be better solution, maybe. Like you could just use a go with a number and then just work your way down. So chapter 5, import data list as list. And then we'll say init list nil. So this can be maybe unit import data maybe. List unit. Cool. So if we do that, that's fine. And then we can say list cons unit, I think, like this. Yep. And that gives you nothing, which it should. And then if we add one more cons to the mix, list cons unit that, then we should get the unit. And there's just a single one, right? Because yeah, we would have to make a list of 3. Okay, cool. So I think that's an it. Now, the question is, was that good? Probably not. Oh, right. I goofed up because this should be just nil. But that's fine. Like, it just changes that one case. Okay. So then if we do this, we get the error, which is what I was looking at the initial, or for the initial one. But this doesn't work because this is a just. So you actually need to combine all of the justs. So you could probably actually use traverse here. This seems like a good candidate for traverse, but I don't think we're supposed to use traverse. Because then you would just have a just x colon whatever, and then it would be totally fine. Well, actually, wait, can you do that? Because the traverse would have to be on the outside. So you would need, I think you would still need a go function, and then you would traverse at the end. So you'd have to go through the list twice, if I understand correctly. Yep. So let's look at this one real quick. Yeah, so there's no way to get the just here. You would need to put a just there, at least. What's the issue with this one? Oh yeah, because it doesn't have the nil case. So this is a incomplete pattern match, which is, yeah, we saw that earlier. Yep, and then that's essentially what we wrote is shouldn't be possible. And there we go. So yeah, this is basically the code that he wrote. Again, I'm adding more cases, case underscore ofs, but it's essentially the same code. I don't love this necessarily. Like, if it shouldn't be possible, then we should probably do something when the impossible happened. All right. Anyway. All right. So uncons is an interesting one. So yeah, we have an anonymous record, I think is the right term for that stores the head and the tail, if they exist. And I think that this is pretty easy. If we just get nil, then it becomes nothing. Otherwise, you have x excess, and you return head. I can't remember if I think I just use colon here. X tail excess. Oh, but I need just. Yep. Okay. So there's the only time you use an equal sign in a record is when you're doing record update syntax. So if we wanted to update this record, we could write, I think, head equals x. Does this compile? It does. Yeah. So like this is saying build this record and then update the head of that record or the head field of that record to X, which is obviously doing nothing. But I was just trying to point out that it worked. Oh, yeah, we need to get rid of that as well. All right, there's uncons. Cool. All right. This one's not very recursive, like pretty easy one. Index takes a list and an index value and returns the value at that index. Okay. So index is gonna be int list a maybe a. So the question becomes, do we do this with an if statement or some other way? Because I think you can just do this with a go function. Hey, Thrash, what's going on? How are you? Hey, Andre. Hello, kitty. They're getting hungry. In 10 minutes, I have to go feed them. Very good. Good to hear. I am working through the chapter 5 of holy crap. Chapter 5 of functional programming made easier. And basically we're just implementing functions on cons lists. So there's just a bunch more functions that we're going to do, and then I'll probably call it a day. I have to work through holy crap someday. That's funny. All right, so index is, the question becomes, do we want this as, like, how do we want this? So is it greater than n? Yeah, I think so. I just don't like this. Yeah, I think you're right. I don't really like doing it this way though. But maybe it's fine. Yeah, that's what I was thinking. I was going to do it with a go function. Because you still need a go function here, don't you? Well, the go function is just simpler if you just make sure that the length is equal. Or sorry, if the n is less. So we still need a go function. So we need we're going to take an integer and a list. I don't like this. Can I put holes? Is that like totally, is that legal? Does it know its type? Hi, Katie. We're gonna go eat soon. Don't start biting my legs, please. I don't like when you do that. Please stop. All right. Yeah, I want to do it with a go function. So if we hit m and nil, and m is greater than 0, that's nothing. If we hit 0, does this work? I can't remember. What is this thing? Well, this is certainly not going to work. Because we need to actually like cons x excess. So this is like our error case. This is like everything's okay case. And then here's like our case where we need to keep doing stuff. So here is like we also need to check that if n is less than 0, then nothing else go. Or equal. Well, no, we're 0 indexed, so we're fine. Okay. And then if we get 0 and this, we don't need to like explicitly do this. We'll just do it like that. This becomes just x. And then if we have this case, except we're gonna have to have we have to subtract 1, and also we're gonna have an issue with the types because they're not gonna line up because we need to recurse, because this is gonna be go. Oh, actually, I think it's fine. M minus 1 excess. I think it's fine if we do this, right? Okay, so it seems to think that we've not covered all our inputs. Which one have we not? Underscore nil. Can we hit that? What would this mean? This is the index out of bounds. Or wait. Yeah, so I think that this is fine. This is just impossible. Right, this should be ys so we don't shadow. So something like this. Yeah, we protect against the negative index here though. So we can't actually have a negative index. Although I suppose we could just say given m anything and m is less than 0, that's just nothing, right? And then it's fine. It still thinks that this is incomplete, but I feel like that is complete. But it doesn't like this. So I think what we'll do is we'll just leave the if statement and then just say go anything nil is nothing, because this is impossible, I think. This function might not be total. I'm not 100% sure, but it certainly should be the last thing that we do. And actually, we should probably do that here too. But this won't matter because in this particular case, like, I don't think you can even get this because we should always hit this first. But we could put this down here as well just to like kind of point out. This one we could hit and it would be bad. So we want to make sure that this is the last possible thing that we do. Well, no, I don't think it's bad. What does this mean? This means that n is not 0 and we hit nil. But that would be true in this case. Yeah, so the only way we could hit this is if it was negative, and that's totally fine. Because we've already protected against that. So I think that this is fine. Oh, there's the feeding cats time. Let's just make sure that this is done. I feel like it's fine. It's probably weird though. Like, I don't know that that's a good implementation, but it is a implementation. Why is this? Okay, so we're trying to. Oh, well, we can just grab these things. That way we don't have to do this. Okay. I don't really. Can I not press home? That sucks. I don't actually need like any of this. And then I put the index first. So that should be nothing. And 0 should be 1. 1 should be... That should be nil, right? This one's easy. This is the one that I think is broken. Oh, I forgot a 0. So this should print to 3, prints nothing. Wait, why? Oh, okay, so nil doesn't actually count. Okay, that's fine. So So I think that's right. We would need a much better testing strategy to ensure that this is correct. But let's see what Charles has got here. And then I'm going to go feed my cats real quick. And I may take like a 15-minute break real quick as well. I should probably get a timer for that, though. Okay, so nil and anything is nothing, which is true. Right? Yes. So actually, I think that it's fine to just remove this, right? No, we still need this because we need to say our index is out of bounds. This is our index out of bounds situation. And actually, this isn't impossible. I don't think. Because if we ask for a 0 and a nil, then this will fail, right? So if we do 0 nil, we're actually not, we're hitting this case. So this is not like impossible. This is the case where, this is this case. Yep. And then we have that case. And then we have this case. Yep. So yeah, we can actually remove this. We can remove the go function because this is still tail recursive, but that was just a function I came up with. So actually, this is pretty darn close to what we have. The only difference is that we need this case. And we can remove some stuff from here. So if we do the following. Can I do it like this? All right, so if I don't know if this compiles, which is why I'm like trying to see if it will work. GC. Oh, I need to fix that as well. 1 second, bud. This is our comment. Does this compile at all? Maybe there's no. Maybe you just do it like this. I don't think you can do multiple cases like this. Yeah. So we need n here, and then you can say like, if n is less than 0, nothing. And we need to get rid of one of these like that. If you get anything and nil, that's nothing. If you get 0, x, that's just x. Otherwise, you call Oh, nice. Sorry, I missed the link there. So then we call index n minus 1 excess like this. And I think that this will compile. Except I gotta remove this. So this and n equals 0. And then otherwise do that. And that should be exhaustive as well. Okay, let's look at the list version. Your list version, I suppose. All right, so we got index n list. I don't understand this labels thing. Returns list if the... Yeah, unfortunately, this doesn't mean a lot to me. Please don't block our ads. I'm sorry, I'm going to block your ads. Oh, okay. So you're creating a local function like go. You just call it rec. So this is go. And then this will return nil if the list is nil. Okay. And then we are splitting out the first with the rest. And then if this is, yep, otherwise, yep, okay. Yeah, I see it. Yep, this is basically what I'm doing. Yep. Cool. Thank you for telling me what that meant. That's helpful. All right. So this is just a slightly cleaner version of that. Of the one I had previously. I love pattern guards. They're so great. This is pretty slick, actually. Okay. Yep. See ya. Always a pleasure to have you. Okay, so here we need like this indexy function. Okay. So and that also means we need to probably do that. Okay, that's and then also these are backwards technically, but it is what it is. I suppose we can write flip. You can't write that. Whatever. It's fine. So, technically, this is backwards to the normal impl. Now, the question becomes, is it really infix R0? Okay, well, that basically answers the question. It's really low precedence. So we want functions to, or wait, is this high or low? I keep forgetting what the order is. Higher precedence comes first. Okay, so this comes before. It would make sense that it would come after $. Yeah, so technically ours is backwards from this. So it's like the integer comes first. but that's fine. So find index. So now, oh. So now we have a predicate. Oh, yeah? Okay. So we 100% need a go function. The go function is going to take a list, an accumulator, find the first index for which the predicate holds. Okay, so we have P. All right. So if we get nil, then we return oops, probably too far, I guess. Okay, so now we should just get, okay, cool. So if we get nil, if we get x, and px, we return just ac. Sorry, it's if we get anything else, we recurse. Skipping the first index for obvious reasons. Well, maybe not obvious reasons, but we have to skip the first one, otherwise we just enter an infinite loop. So we're basically saying like, okay, we've pulled off this first index, and then we'll keep going. So I think this is right. We're just finding the first case of the accumulator, which is just an increase in a atomically increasing index, I guess. And then, yeah, just keep going until we're done. But if we don't have a list at all, then we get nothing. And if we have not found a case where the index match, we also get nothing. So yeah, I think this is right. Okay. Cool. Okay, so if pred x, then just I. That's this line right here. Else go I plus 1, this thing. Yep. It's exactly what we have, except we're abstracting the index away from the user. Well, oh, they're doing that as well. Sorry. So it's fine. Okay. Notice that find index is tail recursive since there is no reason to return the caller after their, yeah. Yep. This looks very similar to our version. It's just we're writing using let syntax. I don't know whose is nicer. This is just the style I've been using this whole time, so I'm going to keep doing it. Okay, so find last index. All right, so the structure of this one's going to be very, very similar. Except the difference is that this one finds the first index. We need to find the last one. So basically that means we need to what does this need to be? So we keep our accumulator. So there's like a current index. Like this. And so we want to say here, we want to take all right. So we want to do something like this, I think, and say here we need XS. Hey, Rots and Plots, how's it going? How's your day? We are writing recursive functions on cons lists. So I guess it's going okay. It just like always takes me a minute to get up to speed with these things again. So this one becomes go. Nice. What'd you cook? Anything yummy? Or particularly yummy, I suppose? last index equals current index XS, something like this. Okay, I don't know what it would be in English. Okay, fair enough. All right, so the idea here is that if our predicate matches, we need to update the last index with the current index. This gives us a current index of 0, last index 0. And then we want to say so this is like, I don't know. Okay. Oh, yeah, yeah. Yeah, I don't, feel like we have a name for a savory potato pancake, but I think we just call them potato pancakes. I don't know that there's any extra stuff going on there. So if the German name is weird. What's the German name? I probably wouldn't even recognize it, I guess, so maybe it's not worth. Is this not equals in this language? I really hate using -1 for this, but like, it can't actually be 0. Oh, I guess we can just call this nothing. And then we can say that the last index is just current index. That's way better. And then if last index is nothing, then nothing. Oh, wait, we can just do this. Right? Maybe? Rye? Yeah, I mean, I guess I don't know how to pronounce German words, so it's not so much that it's like weird, it's just that it's weird in the sense that like the words don't necessarily mean like what you're eating. That's what you mean, because they're like compound words or something. I'm not very German fluent. Yeah, yeah. Okay, I get it now. I see what you're saying. Took me a second, but I got there. Okay, so like we want to pattern match out last index from the results. So like, do I have to say like in something else? No. No. Yeah, the they're in here. I don't actually know how to type them. I think he explained it, but like I just write for all. It's totally fine. So all we need to do is return the last index, which I don't. Yeah, I mean I could copy and paste it, but how do I pattern match out the last index from this thing? I thought it would just be like this. What's the complaint here? Oh, well, obviously that's... Oh, can I just do... like that? No? Not allowed? What are you complaining about? It should be either nothing or just... I don't believe so. Not him. Oh, hey Tim, I didn't see you in there. Sorry, all the names are red, so it's hard to distinguish the different names. How's it going? Also, I don't think I said hello to you either, Notum. How are you? How the heck do I get these again? Like, why am I blanking on this? Oh, that's kind of funny. Hang on. Time to turn green. There you go. Hang on, I gotta do some setup. I wasn't actually expecting to need another window, but for whatever reason, I've completely forgot how to do anything in PureScript. So, PureScript, pattern match. Why is this so slow? Pattern match, anonymous record. Record. Okay, so first and last. So we could pattern match like this, which is what I expected. Okay, I would have expected this too. So why can't I do that? Right? This thing returns, it iterates through the list, returns the accumulator, which is the current index and last index. So I just want to get the results of the last index. What? Why? Why are you telling me this? Oh, I'm silly. That's why. My go function is not taking the list because it's not in a position to do that. Okay, so I never need last index, so we can just get the current index from this thing. What? Oh, this is shadowing issues because this needs to be y, ys, and then over here we'll just remove the shadowing issues. Perfect. Okay, cool. I think the no implicit for all extension proposal got approved for GHC recently. Oh, that's pretty dope. I would use that a lot. I think that would be really helpful. Okay, cool. So anyway, this time we iterate through the entire list using our go function, and then we end by returning our accumulator, and then we just get like our last index, which is either going to be nothing or the most recent version of the index. So I think that this is probably right. That took me a little bit more than I thought it would. Although I guess I got distracted with savory pancakes. What are you doing, silly cat? I kind of want some savory pancakes now. That sounds delicious. All right. I like this. I suppose we could just also just wrap up Go and then like just do last index of that or something. But I feel like this looks fine. I don't really love this very much. Like these last two lines kind of look weird, but that's fine. All right, let's see what we got here. Okay, go nothing 0L. Yeah, okay. I guess we could just also just store this as an accumulator. Like I don't need a record here, but like I have the ability to make anonymous records, so it seems pretty useful to just make an anonymous record instead of using currying. I don't want to figure out why this is a compiler error. Like I just implemented the function. I don't need to see the various versions of this function. So one thing I did read about this book is that we go through a lot of like incorrect examples before getting to the correct one, and so it can lead you down to a path of thinking things are um like we're going down the right direction, but we end up in this place, and then you're like, wait, am I supposed to forget what I just learned here? So I'm kind of concerned about that one as well. So I don't want to do that if I can avoid it. Okay, so reverse. This squiggly arrow is known as a natural transformation. This has to do with the fact that the type on the left and the type on the right are both functors. We don't need to worry about what that means at this point. We'll get to functors soon enough. Oh, cool. I didn't know this. Where's my squiggly? There it is. So, um, equivalent to for all A, list A, list A. Did anybody else know this? I don't know that I've ever even seen this in code before. In PureScript code, I mean, like a natural transformation. That's pretty cool. And I guess yeah, anything that's like a functor will just happen. I don't know that you can do this in Haskell. Maybe it exists in Haskell. Not sure. I'd be interested to know. Yeah, I think so too. Okay, so I always do this wrong. But essentially we just need a left fold. Is that right? To do this? Synonym. Yeah. I've definitely seen this syntax used before in other places, but like not in actual code, more like pseudocode. This seems to compile. So that's pretty sweet. All right. Reverse always trips me up. So we have uh Oh, sick. Okay. I didn't know that. Let's write it the dumb way first. Is there... I mean, I guess we don't need to write it the not dumb way, right? Like, um, list. Is this the right one? No. We need the non-lazy one, I suppose. Or maybe this is just the right thing. Is there a append in here? Oh, we can use our snock. True. True. All right. So then we want to append a new element at the end of this thing. So we snock X on reverse this thing? Is that right? I mean, it compiles, so I think that's right. I forgot about snack. Snack. So we're basically just creating a bunch of snocks, which, if I recall correctly, this is a fold left. So I think that this is right. Let's try it. Import chapter 5 as chapter 5. And then import data list. And then we should be able to write chapter 5 reverse like 1. Nice. Okay. I honestly thought I was going to fail this way harder, but I guess I've implemented reverse like a bunch of times because I always get confused by it. But the idea of I think it's the fold left. Again, I always forget, but you're just replacing the colon with snock, and that's how like a fold left works. But then we're reversing the rest of the list, so it's essentially still the same thing. I think. Don't quote me on this. Okay. Yeah, so we did this. This obviously doesn't work. This is just like identity. It's like fmap identity. This one doesn't work because X, or like this is a list, so you can't use this operator. Sorry, I said that incorrectly. Well, actually, no, both sides of this are wrong. I was fine. Yep, nil. Here's a Go example, which like you can use the Go example. RL. What's RL stand for? Reversed list. So we take... Isn't this just identity? So we take our outer list. Wait, I'm confused. How does this work? Uh, think through doing 2 steps. Sure, that's probably not a bad idea. So we have our original list. Oh yeah, okay, yeah, I see it. Because we're pre-pending, so we're gonna say X, Y, Z. Yeah, I see it. I'm just being silly. Okay. Which this is just doing the same thing. This is because we've already written this function basically. So concat will take 2 lists. Snock is defined like this. So no. So it should be fine, yeah. We're not doing Snock isn't being done the plus plus D way. Okay. So we're gonna have an excess and a case of. If we get nil, we just have excess. If we get a cons y ys, we gotta do y. Oh, except this is backwards. Right? We're not appending in this case, we're pre-pending. Can I make that work? Probably. But yeah, I think it's kind of tricky. So I think we should just do ys like this and then case excess of, so that we don't have this issue. Okay. So then we take z, we then concat zs with ys, I guess. I think that's the right definition. Yeah, like it would be nice if we could do it the other way, like excess case underscore of, but you can't because then you're prepending ys and excess. So I think you have to write it like this, which is fine. It's not that complicated. All right, let's see what we got here. Oh, I'm doing the wrong thing. This is append. So we can do infix L8 append as plus plus, I think. not even defined in here. But my guess is that's probably right. I would have to test it, so it's fine. Okay, so now we have concat, which is for all a list of a. My bad. All right. That could be true. I'm not sure. Let's look at it in a second, because well, we could just write this just to make that happy while we look. All right, so and then let's look at this. Yeah, I think you're right. Yeah, you're 100% right. Because this has to go through the whole list. But that's fine. We could fix that later if that actually becomes a problem. But we should probably make a note. Note. Oh, actually, let's just copy this one as reverse prime. Hey, Meechap, just 1 second. I can talk a little bit about this. Oh, okay. Or somebody can just answer it for me, which makes sense. Yeah. So, PureScript, it's a functionally, a pure statically typed functional programming language that compiles to JavaScript. Okay. So then we have like access, go, nil. So if you've never seen these kinds of languages before, I think this should. Oh, I'm just like, I guess, transliterating this into the style that I've been using. Yeah. So it's in the same vein as TypeScript, as in like, imagine, you want to write typed JavaScript. Also, I totally missed Tyok for a follow. Thank you. I really appreciate that. But it actually has like a sound type system. So, yeah, like TypeScript doesn't have a sound type system, and you can easily circumvent it and do like really, really nasty things that would be impossible to understand, I feel like. I also really hate this. I don't like the where style at all. Yeah, so PureScript is like Haskell with a little less cruft. It tries to clean up some of the kind of stuff in Haskell that was like hard to understand, or like maybe poor-ish choices. Okay. Now, can we clean this up even more is the question. But yeah, the syntax is very, very similar to Haskell. So if you've ever seen Haskell code before, then this would look familiar. If you've never seen Haskell before, then it's going to look kind of strange. But feel free to ask like questions with syntax and stuff. I'm totally willing to answer whatever questions you have. So like as an example, you're going to see this pattern a lot. This pattern is an anonymous lambda. So it basically desugars to like X case X of. So I can avoid taking in this list and I can say like case underscore of and then pattern match directly on it. Which arguably I don't need to do because the nil will just get taken care of in this go function, won't it? Do I need this extra pattern match? I feel like the answer is no. So if we get nil, we return the accumulator, which is just nil. Yeah, so I think that this is actually more work. Okay, so since last time you were building MLTIN, the FreeBSD port of Milton, I keep saying it wrong, was broken for a very long time and has now been fixed just a week ago. Did you fix it or did someone else fix it? Because it sounds like that's something you might do. Yeah, and the language is fantastic. Like, I think it takes a long time to get familiar with. So that's like, there's still a pretty big barrier of like learning that is required. But I honestly think that, you know, I've been learning Haskell style languages for how long now? I don't know, 3 years, something like that. And yeah, you know, I love them now. I don't really want to work in anything but this. So I'm pretty sure that this is the same thing and a little bit simpler. And also it means that we can go back to XS naming, which is nice, I guess. Not that that's like a huge win, but yeah, that's nice. I like that. And we also remove the ON with snocks, because the snocks are ON each time you call them on the remainder of the list, which is kind of unfortunate. And by kind of, I mean it is unfortunate. Okay. It is also quite similar to what we see in general type theories. I'll have to take your word on that one. I'm not super into type theory, but you know, these languages were designed with sound type systems from the start. So I assumed that they would match like the theoretical understanding of them quite a bit better. It's funny how everyone's color today is either red or green. Not that it's a problem, but it kind of throws me off. Me chat, thanks so much for the follow. I really appreciate that. Very nice of you. All right. So now we're going to do another one of these. Concat. How many more of these do we have? My gosh. I feel like we've done so many. So we're on... okay. You can either be green or red, but no other color. That's fine. So we have concat, filter, and then cat maybes, range. I'm not even sure what range does. Take, drop. My gosh, so many. Okay. Got a million more to do. That's fine. We'll see. I might get hungry and need to go eat. There are a few different shades of green, at least in my chat. I think that it changes depending on like every one of us sees something slightly different, if I remember correctly. Okay, so if we get nil, we're done. If we have well, actually, I can write this like this. All right, so we're clearly going to start a new list. Oh, but that whole thing is a list. So it already has a nil. But like that's fine. We can just append I think like this. You take the first list and then you start appending until you are done appending. Probably. It's probably not the way that Charles is going to write it, but I feel like this is fine. Again, there could be some performancey stuff that I'm unsure of. Yeah, that's basically what this is, right? Yep. Yeah, we're trying to avoid folds, I guess, but we're still just folding. Pretty much every single one of these function. Yeah, maybe not. Because this is like, I think the best way you can do append. I don't think there's another option. It goes through each list once. Yeah, anyway, okay, I think that's right. And luckily we had already written append, so we don't have to like rewrite append, which is nice. Let's see what ends up here. Yep. So this is like I feel like this is a typical grab. Yep, because this is a list of lists, this is totally fine. Oh, wait. No, apparently it's not fine. So this is a... This is a list. This is a list of list. Oh, it's complaining because we're missing a case. Probably when this is nil. So this one just becomes concat xsss because we've exhausted the first list. Hi, Kitty. Yep, this is basically exactly what we're writing. It's just that this case is handled by the append function. Yeah. So I'm pretty sure that these are exactly the same. They just look a tiny bit different. All right, filter. So filter is gonna take an A, and it's going to take a to Boolean function, a list of A's, and return a list of A's. So filter P case underscore of nil. X XS PX x colon xs. Sorry, filter pxs. Otherwise, filter pxs. Like that. I think is the sort of naive, simplest approach to writing this. Mm-hmm. Skip any elements that don't match the predicate. Cool. All right. Learn about 3 functions. MapReduce filter. Filter is one of those functions that cannot be done without being able to pass a function as an argument to another function. Non-functional languages like Java could not do this for a very long time. Yeah. I don't want to live in a world where I can't pass functions to other functions. Have I lived in that world before? Yeah, I suppose so. I don't think Fortran can do that. Can it? Defunctionalize. I've heard this term before, but for like it's not ingrained in my head what that means. But yeah, I don't think, especially like Fortran 77 had this ability, but I haven't written that language in a really long time. Yeah, because like the other languages, C++, that or like that I've kind of familiar with, C++, Python both have first class functions, if I recall correctly. Although I guess C++ didn't get them until that recent, right? I don't remember. Anyway, I don't write those languages very often, so anything I say about them, just assume that I'm wrong. Okay. So great. Code for filter, nil nil. If pred x, then x, else filter. Yep. So I'm doing the exact same thing as this. I'm just using the pattern matching style instead of an if statement. Yep. This is a guard syntax, which is another syntax you can use for this. But again, I'm using this case statement instead so I don't have to have this here. And I just pattern match these out. Although I guess I'm doing it twice, so this one requires you to only pattern match once, which is nice. I don't know why I can't speak all of a sudden. Meta programming is purely functional as far as I know. Yeah, I haven't thought about it in a while, so I'm having a hard time like coming up with it. You know what I mean? I don't write it enough. Well, I don't really want to write it at all. Sorry. Do you see where I'm going with this? Okay. Anyway. Um I mean there's like a bunch of different ways you could write this function, so I don't know. Sure, it's fine. All right. So tail recursive version of filter. You may have noticed that our version of filter is not tail recursive. What? Okay. I'm not sure. So we just need a go function. Function pointers. Okay. I haven't done Fortran in a long time, so. Actually, I still remember when I went to I went to Docker. What is it? DockerCon? CubeCon. That's what I went to. And what's that guy's name? Kelsey something. I can't remember his last name. But he made a really funny comment where he was talking about people bashing on other languages, and he was like, people shouldn't bash on other language, and the reason, or one of the reasons why, is that Fortran has like a newer spec than Go or something, and he made that a pretty funny comparison to Fortran. And he was learning about Fortran. Hightower, that's his last name, Kelsey Hightower, I'm pretty sure. And it was like Fortran 20 something. I don't remember. All right, let's look at this Go function. Yeah, it might not matter at all, because like we're doing code gen to another language, and so it probably is not concerning at the end of the day. I think this is more of just um, like trying to teach you about tail recursion. I kind of just want to look at the result and then see what is it. Yeah, I still was writing Fortran just a few years ago. Maybe like 32 years ago, I wrote Fortran. Okay, just show me the answer. Okay. All right. Wait, what? Why are we bringing reverse into the mix? So NL. Oh, sure. Okay. I guess that's true. But is this really like this is tail recursive, but is it more performant? And also, I'm also curious about the what you were saying before. That's also why reverse reverses the list. That's a fair point. Yeah, we would have to benchmark. I agree. I don't want to. I don't want to do that at the moment. That's uninteresting to me. Um, but yes, if you have that question, don't try to analyze it from like first principles. Just measure it. Sometimes you can sort of first principles yourself away from the problem, but also you're running this in a different language, so that language's semantics also matter. Okay. Anyway, okay, cat maybes. What does this take? Like a list of maybe A's and returns a list of A. Okay. What do you mean conflicting definitions are in scope? Why do I have data list non-empty in scope? Oh, I forgot my for all. That was weird. Why doesn't it complain about that? I would have guessed that it complains. Okay, now we got another shadow for append. Okay, maybe that's those complaints have been there for a while and I just didn't notice it. Okay, is there an operator to compose functors? That's a great question. I legit do not know the answer to that. I would hope that it had a tilde in it though. All right. Now there's another thing we could do here where we like case match on the X or something. I don't know that we gain anything from that though. We could also do no, because we want to pull out the X. So I feel like this is probably the most obvious way. Yeah, they're doing this one, which I was sort of expecting, but this requires you to have like a Y, right? Which is a little annoying. This one doesn't. So I don't know. What's better? I have no idea. Okay, what's range? Oh, okay. So I see. So we're gonna take int, int, list, int. I guess. Yeah. Okay. So all right. So I think we need two functions. Go up. Oh, actually, no. I know what we can do. We can say that if y is and is the otherwise with an arrow syntax or an equals syntax? I always forget these kinds of things. We'll see if it compiles. Okay, so it appears to compile. So if x is greater than y, just flip the inputs, and then that way we don't have to deal with this. So then we do need a all right, so then we'll just take x. I think this is an infinite list, by the way. Or infinite loop, excuse me. No, this is correct. Range returns a list. This needs to return a list. But I'm concerned about an infinite loop here because will this loop over? Trying to make sure. So if x is equal to y, then we'll stop. So I think this is fine. Oh, and we can use singleton here. I was going to, but I was like, I don't think that's right. Okay, let's just look at the answer and... So we always want range to be increasing. If these things are equal, then it's just y. I don't know if this is right. Let's just try it. Let's find out. Oh, yes. I see what you're saying. You're right. You're 100% right. Because we're just going to always create increasing lists. So actually, I do think we probably want to go up a go down function so that we don't have this problem. That's what I was going to do at first. And then I was like, do I really need that? And I'm not sure. I really just want to make sure this doesn't explode. So if we do like range 0 and 1, oh, right. Wait, is this working the way I want it to? Oh, this is not the right range function. That's why. Yeah. So it's okay. It's just that we need the reverse. So 0, 1, 0, 0, 0, -1. Okay, seems fine. I guess we really don't need this. Can't we just do... The only thing that changes is our step function. We don't need like a go up, go down. I'm pretty sure that this is just the same. And then once they're equal, then you're fine. Because you're stepping down to y versus stepping up to y. Cool. I think that's right. All right. Yeah, and then this is getting nested here, which is fine. Optimizing. Oh yeah, so this is the go up, go down thing I was talking about. So like if you could create a go function where you only calculate this once and then say like if you're going up, your increment is 1, and then
call the go function with 1. Or, yeah, which is fine. So yeah, you could just do this. I guess is what it is. But again, you don't need to do this. Okay. Well, you need to do it if it matters. You don't need to do it right away. I'm mean A here. How do we want to do this one? Is this going to return a maybe? I think that you can just say, like, if you get a negative number, then just return the list, probably. So we can just say, right, if you get nil, you're just returning nil. If you get anything and n is less than 0, just return the thing. Probably. Like, what does it mean to take a negative amount of something? Maybe the answer is just nil. I'm not really sure. Yeah, it's a list of A. So what does it mean to take a negative amount of something? I think that it means that you return nil. Otherwise, you need to I think so. Is that right? If you run out of ends, then yeah, you're done. Right. So I haven't accurately represented the done case for the n component. That's what the equals is for. Okay. Yep, not tail recursive. Fine. I don't really care about this tail recursion stuff at the moment. Drop. We get nil. We're nil. If we get so if nil or if n is ever negative, then it doesn't make sense. Wait. we're dropping a negative number, so we're dropping nothing. So I think that this becomes excess. And then otherwise, we're skipping this and we drop n minus 1 excess. Think that's right? Yep. If we hit 0, then yep, that makes sense. So does this actually handle negative numbers correctly? Yeah, this does not handle negative numbers correctly. So fine. I think that mine does. All right. Take while. Okay. So take while. We have this predicate. We have that. So if we have x, xs, and px, then take while p xs x. So if the predicate matches, then we want to build up a list. If anything else happens, return nil. I'm pretty sure that's take while. Right? If you get nil, then it's just nil. If the predicate for x doesn't match, you're done taking while. Yep, I'm pretty sure that's right. Yep. Else nil. Perfect. I don't really understand the purpose of this at the moment. Like, this looks like beta reduction, essentially. I think that's what it's called. But fine. Like, I think this is a simpler solution that is also correct, which is nice. At least I'm pretty sure it's correct. I obviously need to test all of these things, but I'm not going to do that at the moment. All right, so we got another predicate. All right, so if we get nil, we're just nil. If we get x, xs, and our predicate is true, we are dropping that. If we get anything else, we just return it. Except this is not correct. Like, it compiles, but it's not fundamentally right. The reason it's not right Oh wait, no, maybe it is right. Because we don't recurse here. So I think it is right. The only way we can recurse through this function is if the predicate is true. So yeah, I think this is fine. Let's just try it because I'm just want to make sure. So we should have chapter 5 dot and then this. 399,101 and then so cool. Well, I mean, that's only 2 little tests, but I think it should be fine. Take end. I mean, so we're taking for all a int list a list a, and the naive way to write this is reverse take n reverse, which I think compiles. Yeah. So that's the naive version. I suppose you could just like compute the number that you should drop and then drop those, which is probably better. I'm just curious what this right. Um, I feel like this is like maybe in the right light of what we're trying to accomplish, but it seems like it would be a lot easier just to compute like this is like super naive. Um, let's write that. Take um So that's the number of things we want to keep. No, yeah, that's the number we want to drop, right? I'm pretty sure it's just drop to drop excess. No reason to pull this out. Probably no reason to really pull out length either. So yeah. So what is this doing? Um, yeah, I don't like this code. It's weird. So I think this is forward composition. So we take this tuple, which contains some kind of count, and I don't know what this means, NL. Probably just trying to mean something. And then if C is less than N, if the count I don't understand this code. I'm getting tired and hungry, so I apologize if I'm getting less interested. All right. Zip will be fun. And drop end. So drop end is like take end, except it returns what it did not drop off the end. Yeah, so you would implement this very similar, I think, to just take end in this case. Just compute the length, compute the difference, and then instead of drop, you're writing take. So I think drop end is int. Again, I didn't test this, and if it's wrong, it's wrong, but I'm just losing steam. Something like this. Hey Jappy, how's it going? I'm doing well. I am doing well. A bit tired, but that's okay. Good to hear. All right, so yeah, anyway, drop end, they're doing this other thing. For zip, I would guess the type signature is for all A B, list A, list B, list tuple AB. Thanks, James. How are you? I'm glad you liked the video. I posted this video, and actually I'm gonna post it here too because I kind of am interested in the whoops. Why is it doing that? Chiroptical. Somebody mentioned that I should write a slightly shorter one and put it on Twitch. So here's the video that James is referring to. So that like when people launch onto my page for the first time, they can like figure out what my stream is about. That's kind of like the longer form version of it. All right, so this, yeah, it would be nice if I could do this stream time all the time, but I would normally be working at this time, but I am off today, so I can do that. So we basically have like, I think this one actually warrants using the other syntax a little. It'll be a little bit easier. All right, so if we get I have not considered doing write you a Haskell, but that would be a fun one to do. Okay. So in this case, we want to generate a tuple of x and y. And that's the end. Same is true here. And here we recurse oh. We need to end the list. So now what's the issue? Oh, we don't cover all inputs, apparently. So we have the case where they're nil. We have the case where the second one contains one element. Oh, we need the case. Yeah. We need the case where this is nil. Or, whoops, this is nil. And these are both nil. Is that all of them? Okay. The case expression has a unreachable case. I guess we don't really need these ones at all. Okay, so it's kind of incomplete right now, but I know some people who are eager to complete it. I mean, I think that it would be a cool book to finish for sure. So there is zip. And I think unzip is arguably easier. Wait, what is this thing supposed to do? I actually forget what it's supposed to do. It splits them up into a tuple of list A, list B. Okay, so um, um, oh yeah, that's not gonna work. I mixed like the tuple syntax in PureScript with the tuple syntax of oh. Ah, okay. So we take XS, which is a list, and then we take an A. What is this complaining about? So this is a list. This is an A. If we no longer have any more lists to consume, we just tuple up the lists. Otherwise, we continue building them. Oh, well, here's another issue. This needs to be called CS, I guess. Okay. Yeah, so I think this is fine. Katie. No. I don't know a single Gary that's related to me. So no. Also, hello. Yeah, I really can't come up with one. There's got to be one, but okay. Anyway, so we did like a whole bunch of recursive functions. Towards the end, I got a little tired, and so I didn't really feel like testing them that much. But if I had to guess, they're probably pretty close. The only ones that I think are not close are take end and drop end, or like not super close anyway. Let's just test them real quick to make myself happy. But I think they're probably close. All right. Let's look it up. All right. So drop end. That looks right. That looks right. I can't really come up with a great like example, a counter example. I wonder kind of what happens if we do -1 and like what that means. I don't know what that means. Like don't drop anything, maybe. So I feel like this is fine. And then take and this is off by 1, probably. Yeah, so this one's off by 1, basically. I'm not exactly sure why, but it is what it is. Like I could fix it. I'm not interested in doing that at the moment. So anyway, there's chapter 5. We're done with chapter 5, and now we get into chapter 6, which will be type classes, which is pretty cool. Like type classes are sweet, and they kind of